Hi everybody, this is Mrs. Atkins. I will be your honors geometry teacher in the fall. In honors geometry this summer, we're going to go ahead and do the first chapter together as your summer homework. This chapter is largely review of things that you had in elementary school when you learned the elementary concepts of geometry. So I don't think you're going to find anything really earth-shattering. But we do want to make sure that we're all on the same page when we start. So we're going to go through this together this summer. When I hear the word geometry, I just need a little brief definition of what we're talking about. Geo means earth or land. And metry, as you could see, measure. So in geometry, we're going to explore and discover the measures of the earth. As we do that, we begin the discussion with what are called three undefined terms of geometry. Calling these three terms undefined can be a little frustrating for some students because we're going to discuss these three terms, and instead of defining them, we really sort of give an example of them or describe them would be a better way to put it. But don't get hung up on the fact that they're called undefined terms. That's not the most important thing. The first of our undefined terms, or our basic terms, the three terms that we build the entire science on, is called the point. By definition, a point is a location in space. We have an infinite set of points in space. If we would like to think of our algebra graphing coordinate plane, a point is simply the point that you had when you were graphing. A point is a simple location. It doesn't have shape or size. It is usually represented with an uppercase printed letter, not cursive. So this would be point A. The capital printed letter, we usually don't use the cursive. We reserve that one for the plain, but the uppercase print is how we label our points. So we have point A, a simple location. It doesn't have dimension. It's just a simple building block for our science. If I put an infinite set of points side by side by side, and when you think about the ones that fall in between there as well, I'm creating a line. So line is our second undefined term. A line is an infinite set of points that extends infinitely in opposite directions. The word opposite is critical, because if I said in two directions, that would not mean that I would necessarily form a line. A line has one dimension, it has length, but it has no thickness. When we write a line, or we want to symbolize it, we will usually use a lowercase script letter. Now, it doesn't have to be L for line. I just usually make them L for the obvious reason, but it could be any lowercase cursive letter. Another way we can write line is by naming 2 points on the line. So here I have line, symbol on top, AB, or order of the letters doesn't matter in this instance. I could be saying line BA. Okay? So we have point as our first undefined term, line, just like a line on your graph. And the third undefined term is the word plane. Now, a plane is also an infinite set of points. I think I can make that a little bit better, don't y'all? An infinite set of points on a flat surface. It extends infinitely on the flat surface. So it's like a sheet of paper that goes on forever, or a floor that goes on forever, or a wall that goes on forever and ever on all sides. So think about the fact that it's expanding on all sides. A tabletop, a wall. The plane goes without end and has no thickness. It has no edges. There are no edges to the plane. To name a plane, we're going to either use an uppercase script letter. So when we draw a plane, we usually draw a slanted parallelogram, because that on the paper kind of indicates depth. So we've got a plane here, so I'm going to use, in 1 1/4, I'm just going to put an uppercase script P for plane. Or I can use 3 points on the plane, but those 3 points can't be in a straight line. So I can call this plane X, Y, Z. These 3 points are not, or cannot be, in the same line. So we say they have to be non-collinear. Think about your foreign language. Non meaning not, co meaning together. And you see the word line in there, not together on the same line. Collinear points are together on the same line. Non-collinear points are not on the same line. Coplanar points are on the same plane, on the same flat surface. They're either on the same flat surface, or they can be put, or flat surface I should say, can be put through the 3 points at the same time. I'll show you this in an example in a few minutes. Collinear on the same line, non-collinear cannot be on the same line. Coplanar on the same plane, non-coplanar can never be on the same plane, or never on the same flat surface. Okay? A huge, huge concept that we're going to be using so much this year is the concept of intersection. When 2 lines intersect, or 2 planes intersect, or 2 rays intersect, or any of the other figures that we're going to study this year, intersection simply means that they're going to have points, could be just 1 point, but a point or points in common. So when I look at 2 lines that intersect, I have line L intersecting line T. Line L and line T intersect at a point that I call point A. If 2 lines are in the same plane and they intersect, then they can only intersect at 1 point, because we've got straight lines. We don't have squiggly lines, do we? So if two lines are in the same plane or lie on the same flat surface, if they touch, if they intersect, they can only intersect at one point. Likewise, when planes intersect, and this is the way I like to draw planes intersecting, I like to do sort of a crisscross, and then I come down below and do the same thing. See how those are identical? Then I'm going to connect corresponding parts. So this lower one here, this one here, go back to my red. My reds connect. And then right in the middle, you see there? I have where those can intersect. So those two flat surfaces come together, and when they come together, they share or intersect or have in common a line. So I have plane, let's call it X, and let's call this plane Y, because I can make them up any plane that I want to. And they're going to intersect at line L. Another way to think of the intersection of planes is when you think in your room where a wall and the ceiling come together, that crease that's made, that's a line that is made by the intersection of two planes. I also like to use the box concept, and I have yet to draw a box here on my iPad, so bear with me if this doesn't come across as pretty as I'm hoping that it will. Let's try another one. Okay, if you draw two rectangles or squares, like so, and kind of overlap them a little bit, then you can join, again, the corresponding corners. And you notice that there's some piece back here I can't see. Anytime we do a drawing in geometry, and there's something we can't see, we're going to dot it. Some more of those lines could have been dotted, but again, that's not our purpose right now. Our purpose is to look at two intersecting planes. So in this case, why don't we look at the front side, the front plane here? That is this gray plane. And remember, it goes on forever and ever, never, never. We just can't draw it infinitely. We have to draw it bound, but we've already said planes have no edges. And then I look at the flat surface on top of the box. So where these two flat surfaces come together, there's a line. And there's the line. So I have this flat surface I'll call, R. I wrote that off a little bit just because I knew you couldn't see my writing. Let's call this S. So plane R and plane S intersect at line L. Intersect means have points in common. Again, a huge concept we will be using all year long. Notice on your lessons I have attached the textbook page. This will be the textbook you'll be using when school starts. So do go through and read these examples. They're pretty good examples so that you make sure you have your concepts. All right. A couple of things I want to point out here that sort of off the subject, but then again, maybe not. I want to remind you of things that I expect you to remember from algebra when school starts. I expect you to remember how to graph points and lines. I expect you to know about parallel lines and their slopes and how to get their equations. I expect you to remember perpendicular lines and slopes and how to get their equations. I expect you to remember the distance formula to find the distance between 2 points. I expect you to be able to find the midpoint if I give you 2 points. I expect you to be able to find the slope if I give you 2 points. All of those things I expect you to carry with you over into geometry. I also expect you to be able to remember how to factor and how to solve a system of equations. So if these are weaknesses or things that you don't remember, I would strongly suggest that you look at Khan Academy this summer and go back and review those concepts, because when school starts and we hit the ground running, I'm going to expect that those are things that you already know. Now, I want to look at example 4 down here for a second, because I simply want to count the planes with you on this drawing, because a lot of students miss this problem a lot, or miss this concept. When I'm looking at this particular figure right here, if I'm asked how many planes are there, how many flat surfaces go together to make that plane, I've got that front plane, which is plane DHG, that's on the front. Then as I move to its left, I have plane DJH. Then as I move to its left, I have plane DJE. Then as I move to its left, I have DEF. And then on around, I have plane DFG. And then I'm back to the front. Now I also have the flat surface on the bottom of that particular pyramid. That plane, which I only need 3 letters to name, is one plane. It's not a plane because it is plane X, and then it has the bottom of the pyramid on top of it. It's one plane because it's one flat surface, and that flat surface extends through the bottom of the pyramid as well. Okay, so I want you to make sure that you realize that this little flat surface here is a part of the entire flat surface. We don't count those as 2 separate planes. Let's proceed by looking at some of the exercises that are in the book, so that you'll be prepared to do the worksheets that I have laid out for you in the Google Classroom. Okay, I'm looking at number 1, a line containing point X. Now we're supposed to use the figure to name the following. So if I'm going to name a line, I need to name it properly. The line that contains point X, if I'm going to use the lowercase script there, then I'm going to have the line containing point X would be line M. Or I could use the 2 letters that we mentioned earlier, any 2 points on the line. So I could name this line XY, or we said order doesn't matter. We could say YX. Let me fix that a little bit. I don't like the way that looks. YX. Or we've even got R on that line, so we could say XR or RX, or even YR or RY. Now they didn't ask for all of them, but I just want to make the point that any of those are acceptable. So I want you to be comfortable hearing any of those and be empowered to accept the fact that you got that right, even though there was a wide range of choices. Likewise, we need a line containing point Z. Now, if we look at this diagram here, you're looking at the top of a plane, and you're seeing that if this is the side view of the plane, you've got line M and line N on that plane, but line L is piercing the plane. Again, this is a side view. So this would be point R, and then Z is down here below somewhere. So if I want the line that contains Z, I'm looking at line L, or I'm looking at RZ with the symbol on top, ZR with the symbol on top. Now if I want the plane that contains both point W and point R, then that's going to be plane B. Or if I want to name that with the 3 letters, I'm sorry this is getting so crowded, I'm going to name it plane and then 3 non-collinear points. Any 3 points that's on the plane that are not in the same line. So Z wouldn't qualify as one of these because it's not on the plane. Name the geometric term modeled by each object. The beam from a laser, very much like, oops, let me change that, like so, beam from a laser. That's going to be a point, isn't it? The floor is a flat surface, so a flat surface is a plane. Now, drawing is going to be interesting for you at the very beginning until you kind of get used to the drawings. And I want to point out this particular drawing. Remember I said that we dot the sides, or really the lines that we can't see. So this is a good illustration. But if you'll notice, this says in the coordinate plane, a line in a coordinate plane. When we combine our graphing and our geometry, this is called coordinate geometry, and we'll do this a lot throughout the year. A line in a coordinate plane. Okay, so I'm going to come over here to the side and kind of scratch out a coordinate plane. If we were doing this on our paper, we'd do it a lot better. But for the sake of my letting you have some notes here in front of you to see, we're going to kind of have to, it just kind of gets squished up, and I do apologize for that. But we want to draw and label a line in the coordinate plane that contains A, which is 0, -5. So there's point A. And B, which is at 3, 1. There's B. And a point C that's not collinear with AB. So if I need a point C, let me get my line tool so it'll be a little bit straighter. Okay, I've got a line going through A and B. Now, any point C, I can put it anywhere as long as it's not on this line, or it would never be on the extension of this line, because you've got to remember that line goes on and on forever. So any point C that you want to put on here, it could be here, it could be here or here or here. 0, 0 is kind of a favorite of mine because it's so easy to deal with. But any point C that's not collinear with AB would be the drawing that they're wanting. So I'll take my little scribbles off to give you the exact look of what the answer for number 6 should look like. Number 7 says draw a plane. Now remember, when we draw a plane, we're looking at something sort of shaped like Tennessee, I like to say. So we're going to, gotta get that off here we go. Kind of make it slanted to show a little bit of depth there. So we have plane Z, so I'm going to label this with a cursive capital Z. It contains lines X, Y, and W. I'm not going to draw those yet. I'm waiting to see what stipulations they put on us. Lines X and Y intersect at point V. Okay, so here's a possibility. X and Y intersect at point V. And line X and W intersect at point P. Now, are there any variations for that? Absolutely, an infinite number. But that is one that does work. All right, we're down to number 8 here. How many planes are shown in the figure? Well, now, remember there's an infinite number of planes, but they said shown in the figure. So we've got the flat surface that's in the front, and we've got the flat surface that's in the back, and we've got the flat surface that's on the bottom. Then we've got that back surface back at the very back there, from A to C to D to B, back there. And then we've got our front flat surface. So we've got 1, 2, 3 is the bottom. So I've got 1. I think I can make that better. Now let's just count them. We've got 1, 2, 3, and then we have the back is 4, and we have the front is 5. So we have 5 planes that are shown in that particular picture. All right, name 3 points that are collinear, 3 on the same line. I don't see any better than A, H, and B. So these are 3 in a line. I see this other 3, B, J, and F would be another 3 we could use. Unless I'm overlooking something, those are the only 3 that I see in a line. So either of those 2 combinations would be correct. And no, you wouldn't have to give both, just one or the other. Our points, okay, let me erase this off. I want to be able to see this clearly since I'm asking questions or I'm being asked questions. Our points A, H, J, and D coplanar. Now remember, by asking if something is coplanar, it doesn't mean can you see the plane through it now. It means can there ever be a plane through them? And I want to show you that exception in just a second. But is there any way to get one flat surface through those 4 points? And no, there's just no way to get one flat surface through those 3 points. Now let's look at what 11 asks us. Are points B, D, and F coplanar? Yes, they are. The flat surface back here, that little triangle back there, remember it extends forever. So it does determine a plane, or there is a flat surface that can go through that plane. Now let me just show you what I was talking about a while ago when I mentioned if we can put a okay, let me see if I can get this right here. Okay, let's connect these. All right, if I ask you if the 4 points that I'm labeling now, why don't we label these points A, B, C, and D? If I want to know are A, B, C, and D coplanar, you might be surprised to learn that the answer to that question is yes. We can't see a flat surface, but there is a flat surface. If I could put a sheet of paper across this diagonal of the box. That's a flat surface right in there that I could put through those 4. So we do say yes, even though the plane wasn't visible until I put those 2 other segments in. A, B, C, and D are coplanar. So again, don't just fall into the trap of can I see the flat surface. If it's possible to put a flat surface through the points that you're asked about, then those are still considered coplanar. Let's whip through these last few, so I want to make sure you're prepared for the homework. Name the lines that are only in plane Q. Well, here's plane Q. The lines that are only in plane Q would be line N and line Q, little q, because P goes all the way through both. Let's give another side view here. If we're looking at a side view, here's P. It is going through here at C and here at H. And it looks like that M is up here somewhere. So we need to get a good look at really what's going on when we stack those 2 planes on top of each other. They're parallel planes. This is plane R, and this is plane Q. Again, a side view. How many planes are labeled in the figure? Well, I see 2 that are labeled. There's an infinite number, but there are 2 that are labeled. Name the plane containing lines M and T. Well, that's my upper plane because there's M and T. So I've got plane R. Name the intersection of line M and T. There it is. Point C. Name a point that is not coplanar with points A, B, C, and D. Not on the same plane with A, B, C, and D. I can name any of these points that are down here that wouldn't go through the same flat surface. So I could name G or P or H or L or even M. Any of those, I could not in any shape or form twist a plane such that it would go through A, B, C and then pick up one of those points. So I don't need all of these points, I just need one of them because it says name a point. Are points H, M, G, and P, let's change color, H, M, G, and P, are they coplanar? Again, the answer to this might be surprising, but no, they are not, because remember, M is above the plane. So you have G and P and H down here on the plane, but M is above the plane. So no, they're not all four coplanar. Name the points not contained in a line shown. Okay, I may need to get some of my scribbling off. I may not be able to get all of it, but get some of that off of there. All right, let's see here. Name the points not contained in a line. So if I see a point down here that is not on a line, D is not on a line, D is hanging around up here. Well, that's not true. It is on a line, isn't it? On a line shown. So I made a mistake on that one. All right, not on a line. So I'm going to have A is not on a shown line, even though I know there are an infinite number of lines that would go through A and an infinite number of lines that would go through P. This drawing is not showing a line through either A or P. What's another name for line T? For line T up there, here's T. It's either CE or EC, and put the little house on top. Okay? Does line N, there's N, intersect line Q? Now think about infinity. Remember that this will go on forever and stretch out forever. So as N has the arrows on the end and comes on out, and Q comes on out, are they going to intersect? Yes, they are. So you've got to start thinking in an infinite plane and looking at infinite lines and asking yourself about possibilities instead of being so concrete. It's a different way of thinking, but you're going to get it, and I think you're going to like it as well. I don't want to spend I don't want to do this entire page. As a matter of fact, I'll just go ahead and let you know that I'm not interested in this at all. Okay, we can pick up that concept where we've already picked it up. Let's just pick up a few of these up at the top here. If I want to know which geometric term is modeled here, we have a point, because it's just the tippy tip part. So they're outlining that side, so that's a plane, it's a flat surface. Here I have two intersecting planes. Do you see those? You've got one plane and the other plane. I'm not drawing them very clearly, but you've got two there. And the checkerboard, you've got a plane. Okay? Now these, the drawing, these are important. These are important. I don't want to take the whole time to do those because I think that you probably are okay. But as you study this as part of your homework, If there's one of these that you don't feel like you're getting correctly, or you're wondering if you understand it correctly, please comment in the student comments on the Google Classroom under this lesson that you have a question about, page 9, number 34, or page 9, number 38, and let me knock the answer out to you and discuss that in the comments, so that we're all on the same page. Again, it's important. These are important, but we just don't have the time or the really the logistics here to draw it all out. So let's jump on down here to these last few and make sure we're good. Name two collinear points. It can be any 2 points on the same line. It doesn't matter which two. I'm just going to pick out two. Say P and M. How many planes appear in the figure? This is what I mentioned earlier, a few pages back, a few slides back. Let's count these planes that are shown, even though there are an infinite number, the ones that appear in the figure. So I've got this one right here. There's number 1. There's number 2. There's number 3. There's number 4. Here's number 5. The one on top is number 6. And the one on the bottom is number 7. This number 7 is one plane. The 1, 2, 3 for the pentagon is a part of that bottom plane, so you do not count those twice. So in other words, we have 5 sides, a top and a bottom. So the number of planes that appear, you have 7 is the number that's there. Study that carefully if that's not making sense. And again, leave any notes in the comments that you want me to elaborate on. Okay. Do plane A, that's the bottom, and plane MNP, that's the top, do they intersect? No, they don't intersect. They don't touch. As a matter of fact, they're parallel. They'll go on forever and ever and never touch. Like the ceiling in your bedroom and the floor in your bedroom. They're not going to touch. In what line do planes A, that's the bottom again, and Q, R, V intersect? Okay, so where does that plane that I just darkened in and the back, what points do they have in common? Well, you see where they're touching at RQ? So the line they have in common would be line RQ. Okay? Are points T, S, R, Q, and V coplanar? Again, it's that old question. Does a flat surface now grow through this, or is it possible to put a flat surface through those 5 points? And I don't see a way. So I believe that's going to be no. And let's see, are points T, S, R, Q, and W coplanar? Are they on the same flat surface? Yes. They're on the bottom. They're in plane R. Or it's plane A, isn't it? They're in plane A. They're on the same flat surface, so they are coplanar. All right, the most important thing you need to do here on the top is to read this and get used to the terminology that's highlighted. This is not an exercise. This is just something that you need to read, know. So in class, when I'm using this type of terminology, you're with me in the description of the drawing that they're asking of. So make sure you read over this and are familiar with different ways to say the same thing. If I look at these descriptions down below here at number 1, I can say line Q and line M intersect at A, or I could say intersect in A, or the intersection of Q and M is A. A lot of different ways I could say number 1. Number 2, I have 3 planes, K, G, and F, intersecting in line J. And then for number 3, I've got 3 parallel planes. So they would not intersect, and those planes' names are A, B, and C. I want to draw number 2 for you because I think you'll be interested to see me draw it a different way, perhaps. When I draw planes intersecting like this, again, I showed you earlier 2 intersecting. I'm going to do the same thing with 3 intersecting. So I'm going to make a line. See how I'm trying to make them identical to each other. That should have gone through the point right there. Okay, I'm going to connect my blacks, and I'm going to connect my reds, and I'm going to connect my blues. And then you see where they intersect right in there? Those 2 points are determining the line of intersection. So if I stood number 2 up down here, I would have, F, and I'd have G, and I'd have K as the red plane, and then J is my line of intersection. And that's how I draw those to make that a little bit easier for me. All right, now this is going to be your homework, and I think we've got it set up so that you can go with this pretty well. I want you to do this page. This from the workbook is page 1. So I want you to do this entire page, page 1. I don't care if you print this out from the Google Classroom and write on this paper, or if you do this homework on your own paper and then hand me in the paper when school starts. But you're going to do this page 1 of the workbook, numbers 1 through 12, okay? And then there's another page I have here. We're not going to do all of these. I just want to pick out the ones that I think are important, and I want you to do 9 through 12 on this page because I want you comfortable looking at a drawing that has more depth to it, more dimension to it than just a flat drawing. Okay, so that's what you're going to do as your lesson 1 homework. And make sure that you understand that. Again, post any questions for me, either from the video that I've made or the exercises we looked at in the book, or even from your homework. Feel free to write in the comments any questions so that I can help you understand. We want to make sure that Chapter 1 is a good, solid foundation before we get to school and start in Chapter 2, which will be reasoning, truth tables, and proof. We want to be ready to go with that Chapter 2. So make sure you understand this carefully, and I'll help you anytime you ask a question. I'm glad to help you. That's all of Chapter 1, or Section 1 of Chapter 1. We'll start with Chapter 2 next, Section 2 next.